Our objective is to find area ABCD or ABDC we are taking this strip. This is x comma y. When x changes by delta x, y changes by delta y. So this is x plus delta x, y plus delta y. If you focus on EFQP, then you find that this is having greater area than this rectangle, EFSP. But it has smaller area than the upper rectangle, which is EFQR. Area of this rectangle is the width delta x into this, which is y. Area of the bigger rectangle is the width multiplied by this height, but Q is this. Now this area is also area AFQC minus AEPC, right? And when we took point E at distance x from here, then this area AEPC we called AX, and when x changed by delta x, this area AFQC, that we called AX plus delta x. That means this. Our objective is to find this whole area, and the curve may be larger. CD is just a part of the curve. Now we will divide by delta x everywhere, and then we will take the limit. When we take the limit delta x tending to 0, if delta x is tending to 0, delta y automatically is tending to 0. So when we put limit, remember the squeeze play theorem or sandwich theorem. When we take limit equal to sign equal to, but when delta x is approaching 0, delta y is also approaching 0. Left side doesn't have any delta, so y itself, and this is nothing but the definition of dA by dx. So squeeze play theorem fits perfectly. So we have the next board. So we have this. Now this looks like antiderivative thing. Antiderivative we have already discussed. And this antiderivative we will take between 2 points A and B. That means now AB minus AA. How did we define AX? Area of AE PC. Where E was X. And now we are saying X is A, X is B. X is B means here. X is A means here. So obviously it will be this area. A of B minus A of A. It will be this area. ABDC. And that is given by integral A to B by dx. From this discussion, you get a better understanding of definite integral as limit of sum also. How? If you recall limit of sum concept and visualize now several strips like this. In that limit of sum, every term can be thought of as some rectangle. I can keep on going and going. Imagine that this width B minus A is cut, or rather divided into n parts. Part 1, part 2, part 3, part 4, part 5. And then you say that you will take n, make approaching infinity. So all those small gaps which are left here, those small gaps will go if you make n massive. Making n massive is same as making width very small, h. H approaching 0, if you make n approaching infinity, h approaches 0. So h in that discussion was nothing but width of a rectangle. That is h. And how many such rectangles will be there? N rectangles will be there. And B minus A by N is h. So we had B minus A equal to NH. Now in this type of discussion, we did this approach that this area lies between top, bottom, and imagine that discussion extended for all rectangles, this plus this plus this plus this plus this and so on. Then what will happen? First rectangle will have how much area? F of A into H. Second rectangle, F of A plus H into H. F of A plus N minus 1 H into H. That's the last fellow. This one. One can take rectangles in different way also. We started from left side. If we start from right side, look at that rectangle first. Second rectangle. Then third rectangle. Absolute right side rectangle is F of B into H. Then F of B minus H into H. Right? The area that we want will lie between these two. Isn't it? So, F of A plus R minus 1, or let me say RH, F of A plus R into H, where R goes from 0 to N minus 1, is less than area, is less than. Now you can read it from this side also. What is this? A plus H. But now A plus R H. RH. R will be from 1 to N. A plus NH is B. Is this okay, or if there is any question, then let me know. Now that's the usual case, but when you take limit n tending to infinity, then you find that these two become equal. When you take limit n tending to infinity, then this is equal to this is equal to the true area. Otherwise, there were some gaps. Whether you look at this color or that color, in one case some gaps were left out, in the other case some extra gaps came up, some extra fellows. But now when you take the limit, you get the true area. So when we do this derivation or this discussion, then this is what happens. 0 to n minus 1 less than area less than 1 to n. And there can be opposite case also, where this fellow comes to the left side and this fellow goes to the right side. Can you imagine when will that happen? They are interchanging their position. I hope you have seen the file on integration. Second file, integration B. Yes. So a question came in 2008. In which function was decreasing, like that. And now if you start from the left, you start getting big fellows, big areas, big strips. You see that extra fellows are coming now. And if you start from the right side, you find that something is being left out. So you must do that problem. So this integral is this area. In the derivation, we talked about height of rectangle as y. Height of rectangle as y. But height of rectangle can be y only if y is positive. But we did not say that y is positive, we just took it as y. So actually the discussion that we have done, this is y, this can give you negative answer if y is negative. For example, in a curve like this, if you find this integral, you are surely going to get negative answer. So this formula is giving you algebraic area. Algebraic area. If you want to give the answer for actual area, you can never give negative answer. In this case, there will be no problem. Whether algebraic or otherwise geometric, you are going to get positive answer only. So you have to take mod. But that also may not be enough in all cases. For example, if you integrate sine function from 0 to 2 pi, you can check it, you are going to get 0 as the answer. But how can this and this, how can some of these two areas be 0? So what's happening is that integral 0 to 2 pi can be split as 0 to pi and then pi to 2 pi. This is going to be positive algebraic area and this is going to be negative algebraic area. But then magnitude wise they will be equal, but sign wise they will be opposite. So they will cancel each other. So what I'm saying is that just taking mod finally is not a safe practice. Just taking mod finally is not a safe practice. The safe practice is to not allow any negative thing to come anywhere when you are discussing area. No negative area should come anywhere. Negative area is coming because of negative function. So what you should be doing is this. So the best practice is this. Area between 2 points A and B is f of x positive mod dx. Any questions? Let me know. Mod can be handled if you know how fx is behaving. So you generally need a rough curve. Rough sketching is very important. When function is positive, when it is negative, that idea you get well if you have a rough sketch in front of you. Sketching is the key in this topic. And we have done extensive graphing discussion in functions topic that you must review. What we have discussed should work if we interchange x and y. like that. So it is x dy type of thing, where x is f of y. And the same rule of mod should be applicable here also. Take mod. Try this. I hope you have done the rough sketching, so no negative thing is creating trouble. When x is 1, the function is 0. X is 2, it is 0. X is 3, it is 0. When x is very big, all the three brackets are positive and function will become larger and larger. All are positive, three brackets. So if x is becoming bigger, each bracket will become bigger. So it should approach infinity. Then obviously it must turn. It's a smooth function, right? It's a cubic function, polynomial function. It has to be smooth, so no other choice except this. So clearly it could be a cancellation problem of area. If you don't take mod, you are in trouble. That means B. Yes, B is the correct answer.